Welcome to Global Brains, the podcast, where we interview AI experts, thought leaders, business executives, as well as young talent all over the world to demystify AI and discuss the latest trends in business and beyond. Our goal is to make AI understandable and accessible to everyone. So let's get started with your host, Michael Burkhart.
Welcome back and welcome to all new listeners. Episode number 2 is full of biases. We spoke about the connection of behavior science and data science. So we basically spoke about us, our behaviors and cognitive limitations, and how data science and AI can help us to make better decisions, both in a business context and in our personal life. But of course, we also spoke about our unique strength and why the human element is crucial to identify the problems in the first place. At the end of the day, we leverage curiosity and creativity, and we interpret data from a broader context. And most importantly, we put insights into action. So in summary, we had a very positive talk about how humans and machines can work in symbiosis to solve problems together. And when I say we, I mean Jim Guszcza, who is the US Chief Data Scientist at Deloitte Consulting. Jim has extensive experience applying predictive analytics in a variety of public and private sectors. And Jim is also a former professor at the University of Wisconsin-Madison Business School. And he holds a PhD in the philosophy of science from the University of Chicago. But now it's time to start. Welcome, Jim. Thank you so much for your time.
Sure, thank you.
So the first question, could you fill in the gaps from the introduction and introduce yourself real quick?
Sure. So my name is Jim Guszcza. I'm a chief data scientist in the U.S. for Deloitte Consulting. My professional title is data scientist. I've been doing what people now call data science since the late 90s, believe it or not. I started doing what we now call machine learning at Allstate Insurance Company's Research Center. I moved to Deloitte in 2001. Still working in insurance back in those early days. And through my work in insurance predictive analytics and kind of deploying these models in insurance companies and sort of working with the underwriters who use models to make better decisions, I got very interested in decision science and behavioral economics. And in recent years, I've been kind of taking a new direction relating to behavioral economics, which is bringing behavioral nudge techniques and choice architecture into our data science practice. So I've been doing this for quite a long time and very excited to be here.
So you're talking about behavior science and data science. What is the connection between both?
So yeah, I've made two connections over time. One is that a major function of data science, I don't want to say this is the only function of data science, but a major function of data science is sort of providing evidence and providing signals and indications and data products that help people make better decisions. In some cases, we can simply just automate decisions, and that's a big part of what people now call artificial intelligence. But a lot of times, data science is used to help people make better decisions, maybe de-biased decisions. And I got interested in behavioral economics originally because a major theme of behavioral economics and this kind of branches of psychology that underpin behavioral economics is that unaided judgment is actually pretty bad at making decisions. And that's why we need the help of data science. And that's that's kind of how I got interested in this, is that the implication of that is that a major reason for the success of kind of data analytic techniques in the business world is not just because of big data and algorithms and pattern recognition. Those are the themes that get a lot of press. But a big reason for the success, and this is kind of forgotten very often, is that the sort of alternate to using algorithms to make decisions is pretty bad, unaided judgment. Daniel Kahneman wrote this book, Thinking Fast and Slow, to summarize a lot of this research. And he basically said there are two types of mental operations, thinking fast and thinking slow. He called them System 1 and System 2. And System 2 is what we think we do very often, which is make logical decisions using kind of deliberation and kind of weighing the evidence carefully. Kahneman's news for us is actually most of our mental operations are thinking fast in nature. And the big headline discovery is that thinking fast is pretty bad at statistics. And that's just kind of a fundamental truth that I think people give lip service to, but it's often forgotten in data science and AI circles. So that's one connection I've made over time.
Okay.
I haven't made it. It's been made for me, but I've been trying to act on it and amplify the message. The second is what I call the last mile problem of data science, which is that algorithms only provide economic value if they're acted upon, if they're somehow used to guide decisions. And again, they could be automatic decisions. You could just like turn the algorithm on and it's like a robot, just kind of like recommending movies for you or something like that, or scanning handwritten digits in an envelope and sending the envelope to the right routing center for the U.S. for a postal service.
Okay.
Or, they could be used to kind of inform human decisions. And again, human decisions can be thinking slow or thinking fast in nature. And so just that kind of process of thinking about how do we act on algorithmic indications got me interested in this idea of bringing choice architecture into data science. That's something else we could talk about.
So what I understand from that is that machines can be good at automating certain tasks, and big data is something that is maybe overestimated to a certain degree. And not everything is related to data only, but it's important to follow a human-centric approach to first identify problems, ask questions, and then design a solution around it. And algorithms might be good at aiding the decision-making process, but at the end of the day, the human is acting on the solutions or recommendations.
That's right. Yeah. So we can drill into artificial intelligence a little bit. I agree with everything you just said. Where to start? Artificial intelligence is an old label. It's an old phrase. It goes back to 1956. It was introduced by Marvin Minsky and his collaborators at a conference held at Dartmouth University back in the mid-50s. And it's gone through several ups and downs, and that tagline is now back with us. It's become a real force in the business world and larger society. But my background is actually philosophy, and so I often reflect on how much our use of language affects the way we think about things. And I think that even though people they might not explicitly say this, I think unconsciously, people still have this lingering idea that artificial intelligence is about building machines that are smart in ways that more or less approximate the way humans are smart. And that's really not true at all. Going back to the Kahneman story from a few minutes ago, we're actually really bad at things machines are actually really good at. I just said we're really bad at weighing evidence. We're really good at kind of like, figuring out how much weight to give, a different, predictive variable, for example. When we make a decision or a judgment, we think we're kind of weighing together, the right bits of information in our head, more or less the way a regression model kind of weights together bits of information. But we're actually not. We're telling stories that are kind of like narratively coherent, and that they seem very plausible to us. And actually, the more kind of, even if they're particularly irrelevant details you add to the story, it seems more coherent and more predictive and more plausible, and it gives you the sense of overconfidence. Machines don't do that at all. They're actually really good at weighing together variables, and that's something that's deeply counterintuitive to people. But at the same time, that's great. So that's like a very useful thing for machines to do. But they're not smart in the way humans are smart. They're not smart in very, very important ways, in the sense that they don't have general intelligence. General intelligence is what's characteristic of human psychology. Yeah. We're both good at reading and doing math and cooking and learning to play tennis. We can do a lot of things, whereas machines are kind of optimized to do one thing and one thing only. An algorithm that's used to kind of retrieve information, like IBM Watson, or diagnose somebody with a disease. Those are two algorithms, but they'd be worthless at switching places and trying to do the other thing. So they can kind of run circles around us at very narrow tasks, and that's great. But as you said earlier, they can't set the goals. They can't handle exceptions. They can't apply common sense or context or ethical reasoning. These are all really important things that humans are actually quite good at. And so even though we talk about artificial intelligence, the term itself, terms are fine, but the term itself sort of misleads you from what we're really trying to achieve, which is the synthesis of human and computer intelligence. We want these two things to act together.
Yeah. So let's say from a business perspective, somebody who has not a technical background, who doesn't understand data science to such a detail as you do, what recommendation, what tips would you give that person in terms of what skills to acquire because artificial intelligence, you were talking about insurance in the beginning, but you can basically apply it to human research, to Internet of Things, to marketing, to sales. So what general skills
for a business person, a general business person? Yeah, I think this is great. It's a great question. I think that it would be actually quite good for more business people to take just kind of like a general survey. I don't even want to call it a course. Maybe some kind of like a, certificate program online would do the trick. But just some kind of training that would kind of give people sort of a working intuition for what a regression model really is, or what a decision tree model is, or what a random forest model is, or what a neural network is, or what a deep learning model is. It's not clear that people have actually a working intuition for a lot of these terms, and it can kind of lead to a sort of magical thinking or kind of like over interpretation of what these techniques are capable of in different contexts. And so in some contexts, a deep learning model is just a thing. It can actually revolutionize an industry and have a huge economic impact. In other cases, it's just not apropos. Even some data scientists get caught up in this. Sometimes people confuse volume of data or the complexity of an algorithm with the economic value it's capable of creating. And the fact is, different techniques are more or less useful in different contexts. Sometimes the right algorithm won't even necessarily be based on a lot of quantitative data. Sometimes an algorithm might just be a way of kind of debiasing human judgments when they're making sort of like high stakes decisions that you can't necessarily build a regression or a machine learning model on. So I think just kind of having a better, not necessarily a technical knowledge of how to build models in Python or R, but just sort of like a better working intuition for what these things are, I think would kind of help demystify things and enable people to make more realistic decisions in planning.
Okay, all right. So we were talking about debiasing people. What are your favorite, let's say, biases that jeopardize decisions in business and personal life? Yeah.
Well, I guess, and I'm going to paraphrase Kahneman here because he's the master of acolyte, right? I think overconfidence is at the root of a lot of bad decisions. There are dozens of cognitive biases, right? It's like you can have like great cocktail party conversations. Classical economists tend to diss this field a little bit because it just kind of seems like piling up a lot of like cute little anecdotes, and the suspicion is that a lot of these things actually might go away in real world contexts. But that's not true. Some of these are very deep, abiding features of human psychology that we just kind of would do well to take into account. But I think the granddaddy of them all is overconfidence. You hear a narrative, and or you just kind of have an initial impression, right? Or maybe say you're interviewing somebody, and you're interviewing somebody. It's like, oh, you went to University of Amsterdam? Hey, so did I. Oh, wait, you took this class? Oh, great, I did too. Oh, you like that movie? So did I. You begin to like that person. And you just kind of hit it off right away, and it's just like you don't think this is happening, but it is. That kind of initial impression colors everything that comes afterwards, and you kind of selectively process information to kind of conform to the initial halo effect or the initial kind of impression, the initial kind of emotional commitment to a person or a project or whatever it is, and that's just that's a very powerful psychological force that is happening even though we're blind to it, and even though we consciously think we're not falling prey to it. It's kind of a paradox. It affects all of us, but we're just completely blind to what's going on in our own heads. It's kind of a surprise. But yeah, I think the reason I say overconfidence is kind of like my favorite, or I think the most notorious, is that it's kind of like a general short-circuiting of rationality. It's just something we really need to be kind of conscious of and kind of like work hard to kind of overcome. And I don't think any organization has really cracked it as much as they should have.
So you are talking about biases for many hours a day sometimes. How did it change your way of thinking? Are you very conscious? Do you oftentimes think about, okay, right now there's this bias that happened to me, and right now I'm aware about it, so I can get rid of it?
Oh, yeah. I mean, I don't know if people really care about my personal story, but yeah, professionally, kind of thinking about cognitive biases and how it relates to data science has kind of been revolutionary for me on a professional level, right? It helps me better explain why predictive algorithms in many situations add significant economic value and help overcome inefficient markets. And it also helps us, kind of operationalize models better by thinking about choice architecture. So professionally, it's had those kind of major effects. Personally, yeah, it affects me every day. Every day, I, kind of think about, gee, I'm willing to drive across town to save, $5 on a $50 meal, but I wouldn't, do the same thing, if it was $5 on on buying a new car. It's just $5 either way, right? I mean, there's loss aversion. There's, the kind of pushing a project, and this is professional too, I suppose. I'll push a project at work just because I just love the idea of it, right? I fall prey to this, and I realize it. I'm just as irrational as the next guy, even though I'm conscious of it. So someone will pitch me an idea for a research project they'd like to do, or something that I think would just be like an amazing possible service offering for my company, and I'm saying, guys, we should try this. This could be a great opportunity for us. And maybe I'm being overly affected by just how much I basically like the project, or how compelling the lead scientist was to me on a personal basis. Maybe people are wrong to discount it, or maybe I've got a point, and maybe they're taking an overly risk-averse, narrow framing way of evaluating this risky project. Who knows? But either way, when I have these interactions, both in my personal life or in a work setting, I'm definitely thinking about the possibility of cognitive biases. And I think that's not a bad thing. I think that's I think that writing articles, having podcasts like this, and I can sort of foresee a day, and this is just a speculation, right? But I can foresee a day when companies actually have cognitive bias training sessions for their employees. Not, and the premise would not be that having these training sessions will remove cognitive biases. Absolutely not. But at least giving people this kind of common language to talk about this is a useful first step. In a way, that's already been done, right? In a way, books like Predictably Irrational, Nudge, Thinking Fast and Slow, The Undoing Project, Misbehaving, there's this kind of shelf of books that many of us have on our shelves. But, I'd say that not everybody in the business world has read these things. And, often it's, the exposure is based on a couple of magazine articles, and the phrases are kind of repeated but not necessarily understood all that well. So, it's a process, but, in the past 10 years, this has made huge inroads into the business world and the larger culture. I can foresee a day when it'll be even more common currency. And I think that kind of like having people understand these processes is like a really good first step to figuring out how to address them.
And actually, I think our mind has to be conscious 100%. Otherwise, we will never be able to get rid of these biases, right? Because some things just happen in our subconscious mind.
Mm-hmm. I think that's right. I don't want to... I don't want to create, a one-sided narrative.
Bias-free world.
Yeah. Well, no, a lot of times, what we call quote-unquote biases are just kind of like, simple heuristics for making decisions that are just fine. So, if I have this in my personal life, if I have this kind of like little heuristic saying every time I order fish, I'll order the white wine instead of the red wine, that kind of gets me through life. There might be something that's a bit more optimal. Maybe there's some cases where I prefer a certain red with a certain kind of fish. But you know what? That kind of simple heuristic is kind of good enough. It's just that when we're making high-stakes decisions sometimes, like, should I admit this patient to the emergency room versus sending them home? Should I hire this person or not? Will this person be a good employee? Does this person deserve a promotion? Should I underwrite this insurance risk? Should I sell, injured workers insurance to this cafe in Amsterdam? Yeah. These are all decisions where those sort of like little rules of thumb don't always serve us so well. And now there's a lot of talk about gender and racial biases in workplaces, and improving the hiring, retention, and progression of women and minorities in workplaces. And there's good reason to think that the reason why this is such a big issue is because of the kind of cognitive biases. They're not necessarily malicious. They can operate on people who have the best intentions in the world. But as I said, we're not consciously aware of biases in our own decision making, but that doesn't mean they don't exist. And so, kind of like at least acknowledging them, at least understanding these processes, as I said, is a first step to addressing them. Rather than just kind of, because if you don't understand the nature of the science, you might, this is a big part of scientific thinking, right? It's like if you don't understand the root causes of something, then the actions you take to remedy the situation might not work. So if the root cause of if you don't understand the root cause of, say, for example, gender bias in the workplace, are these kinds of cognitive biases, these kinds of like thinking fast sets of associations, implicit associations, then you might just say, oh, well, what we'll do is we'll institute diversity training. That'll take care of it. Well, a lot of the scholars who study this say actually there's not a lot of evidence that diversity training works. So having a deeper understanding of both where the biases come from and how to overcome bias cognition, this is really more through choice architecture than through kind of, rational training. That might be a more natural step forward.
I guess it's always the case, right? If you become conscious about certain problems, certain issues, and in this case, if you understand why your brain is thinking in a specific way, it might be a way more efficient process as when somebody is just telling you what to do or what is necessary or what you should do. But self-awareness is, I guess, the key to a lot of things. And also when you talk about biases and you talk about, some biases are just natural and they should be there. I mean, our brain is consuming up to 25% of calories, and I think if we get rid of all biases, I think we have to eat a lot of food.
Yes, and that's right.
I guess the fast thinking is oftentimes very convenient.
No, that's exactly right. That's excellent. Yeah, I completely agree with that. This is not like it's all bad news. We just want to be kind of, recognize, when are the heuristics good? When are they, when do they have unwanted effects? And also realize that there are different ways of overcoming biases or making it easier to make decisions. Everything we're talking about is making decisions, right? This is like, how do we enable individual people and organizations to make smarter decisions? That's kind of like the common theme of all these topics: data science, artificial intelligence, choice architecture, and so on. In some cases, the issue is have a robot automate the decision. If it's really, really simple, if it's just kind of like a explicit set of instructions that can do the trick, there's this thing called robotic process automation that will do it. If it's simple questions that are matter of fact, have a chatbot do it, right? Have a robot do it. As soon as, kind of context and empathy and common sense comes into the play, or just give me some of the emotional support, maybe bring a human on board. Or maybe the right kind of human, because not all humans are really good at giving the emotional support. But yeah, then in other cases, you don't want to short circuit human rationality. You want to actually improve human rationality. And that can be through a combination of, kind of algorithmic or data science decision making, or sort of choice architecture. And the idea of choice architecture is that it can kind of improve our decision making in ways that are sort of automatic, rather than try to, choice architecture is all about, instead of trying to, give people tools or data or dashboards or evidence to make more, quote, rational decisions. That's great sometimes. Sometimes it might be more effective to just sort of change the environment in these sort of subtle ways that can make it more natural or easy for people to make the right decision without really thinking about it. So that's the idea of nudge.
Yeah, exactly. Now you're touching on nudging, right? So let's elaborate a little bit on that. So basically, one very easy example to explain this is you go shopping, I think, and you you are hungry. Let's imagine you're very hungry. You go into a shopping center, you go into a grocery store, and the expensive and sometimes unhealthy food is in eyesight, basically. So what you do, you take the food, you buy it, and you go home and eat something that you were not supposed to eat. But this is something you can also apply in the other direction, right? So you can positively influence people in the sense that you give them, you make them aware about something. And how does it apply to data science?
Yeah. So like that's exactly right. The idea is that let's just take a step back. It's kind of sometimes it's easiest to introduce the idea of nudge and choice architecture by talking about what the alternative is. So the sort of like idealized alternative to the kind of choice architecture nudge way of looking at the world is that it's the perspective of classical economics. And what kind of, classical economics in its purest form posits is that in principle there are only two ways of changing human behavior. One is to tell people something they didn't know before. In other words, give them information, right? If I didn't know that there are these great characteristics of this person. I should definitely hire this person, not the other person. That was the kind of Moneyball story. We should hire this baseball player, not that, because I wasn't weighing the evidence properly. The other way to change behavior, according to classical economists, is to offer incentives. If you raise the price or lower the price, tell somebody if they speed, then we're going to send them, we're going to give them a fine. If you misreport your earnings when you're applying for unemployment insurance benefits, you might get caught and it might be really bad for you. So the only way to change behavior is to either give people information that they didn't know before or set up economic carrot and stick incentives. And that's sort of like an idealized picture of humanity. It's really, closer to Mr. Spock from Star Trek than any real life human. In the real world, it's not just the information you provide people or the choices you offer them. The way the choices are arranged, it turns out, can have disproportionate effects on the choices people actually make. So, like back to the grocery store example, if you're shopping at Royal Dutch Ahold, would you rather buy a cut of meat that was advertised 90% fat-free or 10% fat? Logically, the two expressions convey the exact same information, but few people would buy a product that said 10% fat on the label. They'd much rather buy the product that says 90% fat-free. Yeah. Or, as you said, if something, is sort of like, and marketers have known this for a long time. If you make something visually appealing, if you put it right by the checkout counter, if you make it easily accessible within arm's reach, the way books are arranged in bookstores, food items are arranged in stores, that will certainly affect the choices people make. So in a sense, the general thought process is not new. It goes back to Don Draper and Mad Men. It goes back to the advertising world going back generations. In fact, one of the original ad men was I believe related to Sigmund Freud. So in a sense, marketers and advertising people have been using psychology for a long time. The idea of knowledge and choice architecture is let's add a little bit more science to this, kind of like add kind of behavioral insights we've learned from recent decades of psychological research. B, offer up sort of a rigorous way of testing these hypotheses and saying, does this intervention work in a certain context? So, okay, sure, maybe we can, not just use nudges to manipulate people into buying a certain product. Maybe, if I run a cafeteria, maybe at my company, I think Google actually talked about doing this. If we want our employees to be healthier, we can put the healthy snacks more easily accessible, put the less healthy snacks in more of an opaque bin that you actually have to consciously reach towards, and maybe they'll make people a bit more deliberate. Maybe they'll do a little bit less mindless eating. That's the hypothesis. Well, you can actually test that hypothesis by, doing it in one canteen but not the other, or do an N of one experiment and do it some weeks but not the other, and just see what happens to people's consumption behaviors. So those are simple examples of how choice architecture can affect people's decisions. The whole point about data science, this is sort of like the 2 and 2 I put together a few years ago, is that the kind of classical way of thinking about algorithms or algorithmic decision makings is, you help people overcome their bounded rationality, their bounded cognition through the use of algorithms. So, an algorithm in say a medical setting can weigh together 50 bits of information much better than a physician can weigh together 5 bits of information, 5 symptoms. And furthermore, the algorithm will make the same decision before lunch versus after lunch, where a physician, if he or she is tired, might make a more risk-averse or like a safer bet or a default decision. They might switch a hard decision unconsciously with an easy decision if the person is low on blood sugar. So, algorithms can be very, very effective in helping people make these sort of like deliberate thinking slow decisions, making diagnoses, making job offers, making university admissions decisions, making parole decisions in jurisprudence, et cetera, et cetera, et cetera. But a lot of times algorithms are used in ways that you can't really operationalize them in that same way. I had this kind of revelation when I was thinking about a predictive algorithm project I worked on about 10 years ago for the state of Pennsylvania. I used the same sort of methodologies. I even recycled some of the same R programs that I use in an insurance context to help underwriters make better underwriting decisions. But in this case, the application was, let's evaluate the likelihood that a non-custodial divorced parent will fall behind on his or her child on his child support payments. It's usually a he. So in other words, the divorced parent is supposed to be paying child support payments to the custodial parent, the parent with whom the child lives. And the idea is that we can actually, hopefully, change the jobs of child support enforcement officers away from being reactive to being proactive. Currently the way things work, or before algorithms were introduced, the job of child support officers was to kind of react to custodial parents calling in saying, "Hey, I'm no longer collecting my benefits." Well, if they have algorithms, then maybe they can kind of like foresee, they can predict the people who might be currently paid up but are at danger of falling into arrears, falling behind on the child support payments. That's great. That's a really helpful thing to do. And we built and deployed this model, and everybody was happy with it. It won an award. But then later, I was reading up on some of the behavioral nudge choice architecture literature, and I realized, wait a minute, we could have offered a complementary service offering. If in addition to setting up the algorithm, if we actually field tested, ran randomized control trials on certain behavioral interventions, behavioral finance interventions, then maybe we could give the child support enforcement officers better tools to help people prevent themselves from falling behind on child support payments. So maybe, using apps, or maybe using pre-commitment devices, say commitment cards, or a certain kind of mindset training. These are all techniques that we can kind of hypothesize and then roll out in the field and say, hey, does this actually help move the needle and actually help well-intended people to keep up with their payments? It'd be kind of like a behavioral finance application, but it'd be completely complementary to the predictive analytics. So in other words, the models can kind of point out to caseworkers or field officers the cases that need attention, and then choice architecture help us kind of what I call go the last mile, can give us tools to act on those algorithmic indications. Mm-hmm. So it's a little bit different from saying using an algorithm to hire this person, not that, or underwrite this risk but not that, or make this rather than that medical diagnosis. Those are all the classical, very, very good, economically beneficial applications of predictive analytics. What I'm saying is that for these other cases where it's kind of pointing out cases where people need to change their behavior, that's where marrying choice architecture with predictive analytics can really create a very valuable fusion, I think.
Okay. So I have one more question left, actually.
Sure.
That is, I think, interesting for people that are, let's say, entering college right now. So imagine you would be 18 years old again.
Uh-huh.
With the knowledge and experience you have right now.
Yeah.
What would you do? What skills would you acquire? On what topics would you focus?
Yeah. I don't know if I have a great answer to that, because people are so different. But this is a cliche from another organization that I'm going to repeat because I actually believe in it. I think becoming T-shaped is the way to go. To just go deep in one discipline. It might not be your discipline for your whole life, but I don't care if it's data science or cognitive psychology or physics or whatever it is. Just go deep in one field and attain a real mastery of something, but don't neglect the liberal arts. Don't neglect the kind of like broad perspective that will enable associative thinking. Okay. Because the point is that going deep in one field, the process of going deep in that one field, not only will it give you skills that will help you get a job eventually, it'll kind of like give you the knowledge or kind of like teach you what it's like to learn a discipline. So you might become a data scientist now, maybe you'll retool and become something a little bit different 10 years from now. But you have that ability to kind of go deep in something. But it's also important to have kind of a broad perspective, because you want to kind of be literate in all these different fields. Like we were saying before, if you want to become a business leader, it's good to know a little bit about statistics, right? It's good to have taken like hopefully a really good course in statistics, so that when people talk about the kind of premises of machine learning, you're kind of making an informed decision, not just something based on bullet points or based on a newspaper article you read somewhere. So kind of like, getting a broad perspective that kind of facilitates better decision making, and kind of like also the kind of associative thinking that leads to innovation and actually coming up with solutions to people's problems. So I don't know if that's helpful, but that's kind of what I would say.
Yeah. That totally makes sense. It just takes a while, right? So it's to become an expert can take a while depending on the field you are getting into.
Well, just operationally, or just kind of like in terms of tangible advice. If you're going to university, I would just say, take a major really, really seriously, but don't only do the major. Try to get a broad education as well. Maybe this doesn't resonate as much in Europe, but in the U.S., I kind of noticed this trend that university education is becoming a bit more vocational in nature, and liberal arts departments are feeling more threatened. And I sort of, this may be contrarian, I think that the more artificial intelligence plays a role in business, the more we're going to need people to be more human and more humanistic and have a broader perspective. And so I think there's going to be more rather than less need for people who are kind of trained and to have broad perspectives than we've had in the past, when people are asked to be more like technicians in the workplace.
Yeah, exactly. All right. So in one of your articles I read, there you quoted somebody, and you basically said one of the reasons of the financial crisis was basically because there are very smart people that understand the math, and there are very smart people that understand the world, but those people have to understand both sides. Otherwise, there's no communication possible.
That's exactly right. I was quoting John Kay in the Financial Times, the economist who used to be a Financial Times columnist. Yeah, and that's right. When somebody asked him, why is it the case that these kind of asset valuation models built by Harvard, Cambridge, MIT PhDs led to these horrible decisions? And that's what he said. He said the people that built the understood the math and built the models didn't understand the world, and the people in the world who were making decisions didn't understand the models. And I thought that was just a very, very smart diagnosis. And we're seeing more of a need for this thing, where people who understand who are making decisions in the world, they need to understand the math, right? So if a doctor is using an algorithm to make a diagnosis, he or she should have a good mental model of the premise of that technology that he or she is using. In other words, it should not just be some kind of like a crystal ball or an oracle or a black box. It should offer some kind of guidance as to why it's giving the indication it is. So there's something. It's part of this is incumbent upon the people building the algorithms to make sure these algorithms are transparent and explainable and sort of built to the needs of the human end user. So it's kind of a user-centered design idea for AI. But it's also incumbent upon the decision maker to understand a little bit about the math and the data science. And so I think we're going to need more and more of these kinds of hybrids. So again, more need for T-shaped people.
Yeah. So I think those are very good final words for today's podcast. I think augmented intelligence, bringing in the human side as well as the technical side, and learning more about ourselves, about our own mental models, about our biases, but not forget about some technical knowledge, at least to a degree that we understand where are the limitations of technology, how can technology actually help us. And then I think we can look into the future with more positivity and don't think too much about doomsday, AI, singularity, and other approaches and concepts.
Well said.
Okay, all right. Then thank you so much, Jim, for your time.
Thank you. All right, it was a pleasure talking.
This episode of Global Brains, the podcast, has ended, but be sure to subscribe for more insights and the latest trends in the AI world. Always aiming to make AI accessible to everyone. Also, don't forget to rate and review so that we can continue to bring you the best content. If you work in the AI field or want to, join our community by following the link in the description. See you in the next episode.